welcome, dear guests. I'm really delighted to be here today, for having me here today. It's a pleasure. And I'd like to tell you a little about what we're at AWS, at Amazon Web Services, what we're doing in healthcare and in life science. As announced right away, I'm Business Development Lead for EMEA in healthcare and life science, medical doctor by background and medical informatics. First of all, I'd like to share with you our mission at AWS. So we're serving over 1 million customers globally, and with this, we share a huge amount of workloads with the healthcare and life science community. 8 out of 10 life science companies operate out of AWS. And with this, we clearly state our mission for healthcare and life science, which is to enable access and delivery of person-centered healthcare, driving improved outcomes at a lower cost by accelerating the digitalization and utilization of healthcare and life science data. This is really crucial for us, and we operationalize this with 4 strategic pillars. So the first pillar is our so-called mission workloads, where we really focus on solutions built by our customers, by great organizations like EMRs, electronic medical records, lab systems, radiology systems, and so on. So dedicated systems and solutions built on and with AWS services. The second pillar is about national strategies and initiatives. So we support heavily large initiatives like, for instance, the EHDS, the European Healthcare Data Space, and more national and regional initiatives with our services, as well as informing and forming the governance around those initiatives. The third pillar is about innovation and startups. We couldn't survive with our partners, with great startups, and for this, we go very deeply into funding and into promoting startups, building their new great solutions on top of AWS and AWS services. And last but not least, seamless care delivery. So being a physician by background by myself, I know by heart how hard it is to get all information around a patient when you see a patient in the ER. So it's about all the care delivery, getting information from home over the stay in the hospital and get back home. So the full 360 view to a patient about seamless care delivery, this is essential. And that's where we as AWS can support you as organizations and as builders, as companies who build great solutions in healthcare and life science. World Economic Forum predicts that on average, an organization produces roughly 40+ petabyte on data. And we talk about great devices, IoT, watches, which produce a ton of data points per day. Those data points, they are all siloed still today. They're partly unstructured. They are not in the right format to consume. And with this, we do have only 3% of this data available. So, or in other words, 97% of this data is inaccessible for us today. You could say if we have the right 3%, we would be good. But who knows if we have the right 3% to treat a patient correctly. So we need to have an almost good overview, almost 100%, to know that we have the right 3%. And AI, Gen AI, can help us here to get the right access at the right level and at the right point. To show quickly in which areas in healthcare and life science we're operating, you can see those 6 main pillars. So those 6 pillars are the core of our mission and how we operationalize our work in healthcare and life science. But I'd like to focus today on analytics, machine learning, AI, and Gen AI, and I'd like to show you very quickly how we already today with our customers and great organizations use Gen AI in a day-to-day business and in new day-to-day solutions. But before we dive into the use cases, let me quickly introduce you to our dedicated healthcare and life science services. So as you might know, AWS, Amazon Web Services, we are the technology and innovation arm behind Amazon. So Amazon is our mother, or our father, as you want, and on the other side, our greatest customer on the other side. But we do not only offer compute and storage, we offer dedicated healthcare services. And for this, I'd like to introduce you to HealthOmics, HealthLake, Health Imaging, HealthScribe, and Comprehend Medical. HealthOmics is a service which, as the name implies, can deal with genomics data natively. So this is a storage where you can store raw data which pops out of your analytics machines. It's highly compressed. You can deal with it natively without any solution. So what does it help and support for? It supports organizations who build solutions on top to get rid of the heavy lifting to do everything from scratch. So we call it the undifferentiated heavy lifting. That's what we can solve for you as organizations, for you as builders. Same for HealthLake. HealthLake is a dedicated health lake which can deal with native health information. It's built in with protocols like LGR7 or with FHIR, so we can store medical data. And you can deal with the data, you can interact with this data. So with this, you can build your organization-wide, your county, your country-wide, your global EHDS based on HealthLake, for instance. Health imaging, as the name again applies, it's an imaging service which is able to store PACS, pictures, images, DICOM natively into AWS. And again, you can deal with those images directly out of AWS services. So it can again do the heavy lifting for you as a PACS solution provider to solve for you the storage and the dealing with the data. HealthScribe is an amazing service which can automatically generate clinical notes out of conversations. And I have an example, a reference case, where we showcase how this works out of the box. And last but not least, Comprehend Medical. It's a translation service which understands natural language or deals with natural language processing, but not only with regular spoken language, but with medical spoken language, which is a big difference, as you might know. Talking about HealthScribe just a second ago, here's a great example of HealthScribe, and this is not a solution at all from a customer implemented, but this is our service which can be used from scratch. So you can see in the middle part, this is a conversation which has been recorded between a patient and a physician. And down below, you see the raw transcript of the spoken words. So we call this ambient listening solutions. And this is not a trained model, this is not a trained solution at all, this is not a trained service. This comes out of the box as is. So and on the right side, you see the insights. So this service detects automatically what has been spoken by the professional and what has been spoken by the patient. You as an organization, you as a builder, you as a company, you could use this service from scratch and integrate it into your solution. Again, this does exactly the heavy lifting for you, and this is all fired by GenAI today already and can be used out of the box. Another great example is PhenoX Tracker, which is exactly more or less the same, using the same service. We have on the left side a history of a patient. You see in green highlighted that there are some buzzwords highlighted. So obstructive sleep apnea, increased snoring, a possible breathing pause during sleep. So this is a regular prose text. It has been analyzed by HealthScribe and as well Comprehend Medical, our services, again, out of the box. And you see on the right side on possible diagnosis that it could be just out of the spoken, noted conversation, it could be a Prader-Willi syndrome as a proposal for the physician as a diagnosis hypothesis. Again, fired by GenAI on AWS. Another great example is the so-called Hopper demo. So what you see here is more or less a PACS viewer. On the right side, you can see a jest tray, and on the left side, you see a regular chatbot, as we are, I think, in the meanwhile, aware of how this looks like. The beauty is now, there is no diagnosis and no analyzing has been done before on the chest tray. And we have now the first time the combination of an image model and of a large language model on the left side. And as we hear, we can talk to the model, and the model analyzes in real time the chest tray on the right side. This relieves the physicians, the radiologists from the heavy lifting back again, doing chest ray scans all day long, where only in 5% of the chest rays something severe is really happening at the end of the day.
There is also mild thoracic kyphosis, but the mediastinal contour is normal.
Another great customer example is Munich Leukemia Lab. Munich Leukemia Lab is a leukemia lab based in Germany, Munich, one of the leading leukemia labs. And the Munich Leukemia Lab had two big challenges. So the first challenge was they've been running out of storage. Very simple. So they had to decide, do we build a new data center or do we move into AWS or another hoster? They decided to go with AWS, and we moved 2.4 petabyte of data, which means in this case 4,200 patient genomes. Munich Leukemia Lab does whole genome sequencing, and as you might know, whole genome sequencing produces millions of data points and tons of data. So with this, and with our partner Illumina together, we moved the data into AWS, and on top of that, Munich Leukemia Lab wanted to speed up the whole process. So it took them before more than 20 hours to analyze the samples in their labs. Fired now by Illumina, the whole genome sequencing solution on AWS, we could drill this down to 3 hours. So when you get in the morning after breakfast, take over your sample, by lunch you do have the result now. Before then, you had to wait for over 2 days, roughly. On top of that, Munich Leukemia Lab wanted to speed up, wanted to go into the more innovative path. And together with AWS, we built a proof of concept, a solution based on AWS services where we use GenAI. So we use the GenAI algorithms to analyze the results of the analytics, take patient information into account, so the anamnesis, the history of the patient, and this was a POC only, and we produced without heavy training already an accuracy of 93%. So by further training the algorithm, we might exceed a high 98-digit range, and this speeds up innovation heavily fired by GenAI on AWS. Another really fundamental and great use case is Genomics England, you might be aware of, or the 100K project, so-called. So Genomics England has the high need and ability to introduce and include more than 200,000 radiologists from the ground into their project. We have more than 16,000 participants now participating in this, giving data into Genomics England from more than 30 NHA trusts based on AWS. The objective and the aim is of Genomics England to combine a multimodal, multi-omics approach. So not only combining the omics data of a patient, but as well taking in PET-CT, CT scans, MRI, all kind of lab results. So to take the real multi-omics approach. Before running all this on AWS services and AWS infrastructure, it was a real burden, grabbing information from different silos and combining them in a document, for instance. So now on AWS, we have, due to GenAI and collecting information across the board over the silos, we can perform now tasks by 99% faster because we have just built dashboards which are fired by GenAI collecting information. So this relieves, again, the researchers from a heavy lifting of grabbing information and data from different silos. Another great example, UC Health, so from the US West Coast. So UC Health, they introduced a solution called Visage Imaging, which is a PACS solution as well fired by GenAI. And they had, again, two challenges. So the first challenge was they have been operating in the region about 5 different hubs. And each hub had a different PACS solution. So patient sharing, patient information exchange was really a burden for them. So they introduced the new solution, fired again on AWS services. And with this, they operate now on one single solution called the Visage Imaging solution. And there might be the one or the other radiologist under our guests here. So the first and prime KPI for a radiologist is explicitly or implicitly, how fast does my first picture load? And we could make it here that the first picture on a study loads way below 1 second. So to name 0.267 seconds. So this is really fast. So you click on the image and it's there, just there. Beyond this, the radiologists now, fired by Visage Image and GenAI in background, they're operating now on a GenAI model, having support by predicting and analyzing the images like we've seen in the solution, very alike like we've seen in the solution from the colleagues as well in here. And last but not least, Children's Hospital of Philadelphia, or CHOP named. So CHOP had the same challenges as we all have today still. Data is stored in many, many silos, and the CHOP wanted to analyze all the 12,000 exome genome data sets they have been collecting for their children, again combining them with other omics data. At Children's Hospital Philadelphia, we are using our Health Lake solution, which is our HIPAA-eligible FHIR and Lake solution. And we are combining, again, here data on one single source of truth. And we could launch with this 20 new research projects, and we expect much more to come. And it's now able, fired by the services in here and by GenAI, to kick those ones off. This is a bit of a crowded picture, but it should showcase how a multi-omics approach could look like. So you can see on the left side how clinical audio, health records, medical imaging data can be brought into a so-called store, query, and analyzing hub. So this is our data sink, our healthcare data sink, where Health Lake, omics, imaging, scribe work hand in hand. And when it goes into integration or analytics, we can see that we can pull in machine learning and business intelligence or GenAI services just natively and very easily into all the housework services. The beauty is all those services are connected by nature and can be connected and can exchange data. It's all about getting data and science analytics on the right side to build great applications on top of that. And last but not least, of course, let consumers and participants consume data or give data into that lake. To sum up, what are the benefits for healthcare and life science moving into AWS? So we provide a trusted and secure compliant platform. All our services are GDPR compliant, and more than 104 services are HIPAA compliant on top of that. With our services, we can unlock the potential of healthcare data by letting us doing the heavy lifting for you and let you step in at a higher stage in the whole process of building great and amazing solutions for healthcare and life science. With our services and solutions together with you as customers and builders, we can enable the clinicians and operational excellence so we can propel the work on a day-to-day basis and relieve the professionals. We heard about the burnout. We can relieve professionals from unneeded tasks they are not responsible for. With those services, we can enable a personalized digital relationship with several solutions, calling patients with automatic bots and so on, and getting deep insights into the data to the patient. We can leverage a robust healthcare partner network. We have more than 150,000 partners globally we work together with. And it's all about speed. So we learned during COVID-19 pandemic situation that speed matters as well in hospital. When it goes saving life, speed matters. We can support you in this speed of innovation. And with this, I'd like to thank you very much. And I'd like to encourage you and invite you to our booth outside. Let's get in touch and have a discussion about your next workload on AWS. Thank you.